Good morning, everybody. My name is Dimeji. Nice to meet you all. So I was here yesterday at the pre-conference just to talk about, measurement of gas systems. We talked about the state of measurement in Nigeria, how current systems are being run, talk about manual measurements, how people take readings down and all that. And then we talked about newer ways of trying to do things. So one of the things I touched on yesterday was about having central SCADA systems that if you actually implement the right processes in systems, then you can eliminate the human error and some of the mistakes that are being made in the industry. Okay. All right, thank you. Thank you. Okay. So I talked a little bit about that yesterday. And then I talked about where we would like to go as a country, talking about remote monitoring, Internet of Things and all that. So the presentation was well received yesterday. And I realized I would have to present again today. And I thought, where do you go from there? Since I've already said everything I would want to say. So I don't know if the presentation is up. So just a little about myself. My background is I studied electrical electronics from the University of Ibadan, and I have a master's in communications and signal processing from the University of Manchester. So my specialization is in industrial networks, trying to get systems to communicate. And one of the main issues that we have in Nigeria when we talk about crude oil, bunkering, and all those things is that you don't detect when issues happen on time. So when there's an issue that happens on site, it might take an hour or 2 hours where the perpetrators have already disappeared. But if you have accurate systems in place to ensure that when people actually commit these acts, they are detected on time, then we can actually move on as a country. So I also specialize in cybersecurity because when some of the things you'll be hearing in this conference, people talk about putting their plans on the internet and some of the things we talked about yesterday. The problem you have is how do you ensure that such systems are secure? And we touched a little bit on that yesterday. So you can go to the next slide, please. Next slide. So just go back, please. Previous slide. No. Okay, yeah, so I said I am the technical lead at Zip Automation. So what we do is basically automation systems. We, if you want to meter your system, flow computers, anything that has to do with automation, we're there for you. So next slide, yeah. So today I'll just be giving us a primer, just a technical introduction into some of the systems that you'll find in industrial automation, some of the opportunities that are there for young and, should I say old people alike? So, and how we can actually all benefit from it as a country. So next slide, please. So the first thing I want to talk about is what is automation. It's just the design and programming of systems to function automatically. So I used an example yesterday that if you have a house and you have a tank to, to supply water to your house, you might start pumping water and you will most likely stay to turn it off. But you should be able to install a system. People will have something like a float switch where as the water gets pumped, once it gets to a certain level, it's automatically cut off, right? That's the simple automation system. So that's an example of something called domestic automation, which is something you do for your house, and industrial automation, which is what you actually have on crude oil plants. So next slide, please. So where are we going to use automation? You can find it in manufacturing, water treatment, oil and gas, which is what a lot of us are interested in, food and beverage and power systems. The next slide. So this is the automation pyramid. So down there, you can see some of the devices that we are familiar with, flow meters. Above, you have PLCs. Then above, you have what we call SCADA. Then above that, we have analytics and ERP. I mentioned yesterday that in Nigeria, it looks as if we are still on the third level, which is the SCADA systems, which just involves monitoring. But we are not really. So what happens is somebody at the head office wants to see the readings on a daily basis. But what does that mean? How does it help us to forecast? How do you compare the performance of the data that you are getting from different plants? That is where you actually get a lot of value from the systems that you deploy, not just collecting information and not really doing anything with it. It is better that we are not manually writing it down. But if the system is generating large volumes of data, a lot of the value is being lost if we are not performing analytics with it. And I'll mention that later. So that is a key area that we need to actually move on to in Nigeria. So we can move on to the next slide. All right, so no, skip this, don't worry. Yeah, so a major component in automation systems, as you guys will be familiar with, is something called a PLC. So a lot of the major brands are Siemens, which is very common in Europe, some of manufacturing industries. We have Rockwell Automation, very, very popular in oil and gas. And then you have ABB, which is more of a DCS system. So distributed, I'll go into that. So just move on. So this is an example of a SCADA HMI for a typical oil and gas plant. This is for one of our clients. I had to crop the picture to protect for confidentiality, essentially. So here, they accept crude oil, gas from different facilities. They meter it properly, do a lot of pressure reduction, and then they sell to their customers. So here, measurement is absolutely critical. If your system is properly measured, then you know that the gas you're supplying to your customers is what they're actually consuming. If you say you consume 20,000 nm cube, they don't come back to you and say, we actually consume 10,000 nm cube. You need accurate metering, and this system does that for you. So you can go to the next slide. Skip this, don't worry. Yeah, it looks, I don't know, it looks different on their PowerPoint. Anyway, so this is, I'm just trying to introduce us to automation. So this on the right, I mentioned something called PLC versus DCS. So a lot of vendors are going to be talking today, and I hope I don't step on anybody's toes, but there are different systems that you can use to run your plant. So this PLC on the right hand is something that basically functions as a standalone system. If there is, so it's not, think about a small plant, you use a PLC or a small machine or a small pipeline and all that. But DCS systems are systems where every controller functions as part of a unit. So you think Dangote refinery. So you have many small controllers. Imagine what would happen if the refinery were to go down just because of a single failure. That would be horrible, right? But think about Dangote cement. Imagine if the system were to go down just because of a failure of a single system. So with DCS systems, among other things, you have multiple controllers that are just functioning as individual units to reduce failure and to distribute the work. So next slide. So you can skip this as well. Yeah, so this is an example of an analytics dashboard. I showed something different yesterday, but if you look at this, for that previous picture that I showed to you, I showed you a whole plant SCADA, right? But when you look at it, you will not really get any information from it, right? Unless you are very knowledgeable about that field. But somebody here can actually look at this. This is actually the readings from those meters to say, look at this meter, look at this meter, look at this meter. This is the hourly trend. This is the percentage of the maximum. For example, if I know that I can generate 10,000 nm cube is meant to pass through this meter, but right now, this meter has only done 40 or 50% of that. You can easily identify if a particular meter is underperforming or overperforming. For example, you can see that meter that shows green seems to be the one to be performing the best out of all the different meters. Something else you can do here is if you have two meters, for example, I can compare meter A versus meter B. For example, you might have two different customers that you are supplying gas to, and you want to look at their consumption. You can look here and say, oh, this customer seems to be consuming a little more than this customer, and that can guide your future decisions. One of the things I also touched on yesterday was about forecasting. That if you are able to collect data from your system over, let's say, a year, you would be able to accurately forecast to say, based on all the information I've collected in the last 1 year, I should be able to predict what I am likely to produce in the next 1 month. And that is a very, very valuable insight. So I can say, I've been producing 10,000, 12,000, 5,000, 6,000. If I collect that information over a year, I can say, next month, the minimum I'm likely to produce is 5,000, right? The maximum I'm likely to produce is 10,000. And if you tell your shareholders that, or your management, they can say, okay, that might translate to, I don't know, 50 million naira or 100 million naira. So our minimum revenue is 100 million. Our maximum revenue is what? Is 200 million or something like that. And that enables you to plan. So next slide. So this is an analytics dashboard, just a little more information. Yesterday, you can go to the next slide. This gives you, no, next slide. Yeah, yesterday somebody talked about auditing. We have a short amount of time, so I won't go into details. But somebody talked about auditing. Like if you do all these fancy things that we are talking about, you put your plans on the internet, people can access it remotely and a lot of that. How do you protect your system? And how do you know who has performed a certain action? So for a dashboard like this, what it does for you is that it tells you exactly what is happening. So if Operator Shegun turns on the valve, you can see that that person has turned on the valve. If somebody tries to turn something off or changes a set point, you can see all that information from this dashboard. And you can go back probably for the last 10 years, depending on the amount of storage that you have. So next slide. Yeah, so here I just said cool things you can do with automation just to show you some of the possibilities if you want to be like that guy. So there should be a video. All right. All right, so just play that. No. Just yeah. No, please. I think no. Yeah. Yeah.
Okay.
Just yeah. Yeah, that video. The next slide, yeah. I just should be play with it. Oh, you're opening from Google Docs. Anyway, yeah, measurement error, right? So I had I would have loved to okay, so I would have loved to okay, do you know what? Let me just 1 minute show you. Can you go to google.com? Okay, just go. I'll play from YouTube directly. Yeah, YouTube. Sorry, measurement error, right? So youtube.com. Zip automations. ZIP automation. Yeah, so just click on that. No, the first one, yes. No, the first one, up the page. Yeah, the page itself. Go to the videos. So scroll down. Hold on. Yeah, that one here. This one. Okay. Oh, do you know what? Go back. Escape. Let me play another one. Since we are on YouTube, right? So, but you know what? Hold on. So if you play this, you can see this is an example of just a robotic arm. So just a play it. Don't just play it. So just an example of I don't know if the audio is on. So it's basically just a pick and place robot, that kind of stuff. So you have bottles moving. Then when it senses the bottle, you can see that it's just there's an arm that picks up a bottle. Yeah, you see that. So you can see this is a crude demo that we built in our office, just with arms and a bunch of other stuff. So this is just for picking and placing. So you can leave that here. Escape. Yeah. So cool. Go back. One more video. Then play this one. This one. Then I can't find my videos anymore. Play this one. So that would just be the fastest. Yes. So that is so that's just somebody controlling something with their mobile phone as well. I had another video in mind, but this would do just as well. So we have a mobile app where you can actually try to control your plant. And then if you press it, you can't really hear the sound. But she put a password and you can actually see that this is pumping water out of a tank into this high one. We actually implemented this solution. The video I intended to play was actually for a live plant. And you can actually see her controlling the speed of this machine just from her phone. So these are some of the technologies that I feel can make our lives better, because ultimately, as we try to solve our problems, technology is for making our lives better. And you can see the readings, everything from our mobile phone, and she's going to turn it off, and you see it off. We actually deployed this for some water treatment plants in the East, and then this is still in use today. So yeah, so you can go back to the slide. No, it's okay. All right, so next slide. Yeah, no, next slide. Yeah, so we've already done all the cool things I would like to show. So I would just like to wrap up this presentation by saying that I believe that there's a lot of potential in the things that we can do in the country. There's opportunity in the oil and gas industry, depending on how we choose to leverage technology. And if we look inwards, you will actually find that there are a lot of people that are willing to profess solutions that can actually move us forward as a country. So thank you for your time. Didn't go as planned, but thank you very much.
I imagine you have I imagine you have a slide to share, or you're just going to speak, without
okay.
the
Good afternoon, everyone or is it good afternoon?
Well, whichever way is good morning, good afternoon. There's still a good in it.
Okay. I'm somehow 7 hours away from home. So that's why I'll be making this presentation virtually. I regret my lack of being present. I'd have loved to be around live and direct. So I'll be sharing my screen. Can IT give me right to share my screen, please?
Does he have a right to share or access rather? So make him being able to enable that for him.
Okay, is my screen up?
Yes, it is. Your screen is up.
Okay, by way of introduction, my name is Henry Hamza Dagen. I'm an engineer by training. Just like the previous colleague said, I also read electrical and electronics engineering. And then I did a master's in instrumentation and control from Glasgow Caledonian University. And currently I work for Belema Oil. So the topic I'm presenting today is hydrocarbon management and loss reduction, the role of technology, processes, and people. So by way of introduction, when we say hydrocarbon management, it's just a term that refers to the extraction, transportation, and the various stages of extraction, transportation, and refining of petroleum. Well, in this case, we are going to consider this hydrocarbon management in the light of an upstream section. So in upstream, it also means mass reconciliation or mass balance, as the case may be. Effective hydrocarbon management will definitely lead to reduction in loss. And how do we reduce loss? This presentation aims to show the role of technology, process, and people in loss reduction, just like I've mentioned before. Okay, the role of technology. The goal usually is to match the measurement system, the right measurement system to the process media. Because once we get the right measurement system, then we'll be able to measure properly. And then we can account for whatever process, whatever media we have in the process. So secondly, technology helps us to achieve the required efficiency and accuracy and to achieve the best performance. And of course, this is done, should be done at the lowest purchase price and total cost of ownership to whoever is using the technology. Next, we are looking at how do we properly use the technology. So we need an architecture. Okay, so the architecture obviously will need to have sensors, and just like the automation engineer has talked about, we need some communication. And all this, between the sensors and the communication, of course, we need power to power it up. And then in doing this, we need integration. So we need device management, we need data integration, and then we need infrastructure. And then for us to be sure that what we're doing is not just thrown away, we need to store it somewhere. And so we, in recent times, technology has gone to storage in the cloud. So to select a measurement system, we need to look at a few issues apart from, of course, obviously the process properties, but then we need to look at, in the light of hydrocarbon loss management, we need to look at safety first. Of course, we have to check that the flow rate is controlled. We need to look at the basic variables, the temperature, the pressure, and the pressure. The system should be able to match these characteristics. Then, of course, we'll look at the product integrity. Whatever measurement system we're using, it shouldn't change the product characteristics. And then the efficiency of the system we're using. And then, of course, like I mentioned before, the process variable control should be able to take place during different energy transfers while we're having the measurement. So for us to have very good measurement, we need to have a very good metering configuration. In Nigeria, most especially, and around the world, we seem to recognize the LACT unit as being the best configuration for transfer of crude or petroleum products from one owner to the other. So this is, why is this so? Because for every metering configuration, there is an advantage and also there's a disadvantage, but the LACT unit seems to have trump all other configuration that we can use in having measurement. This is because it takes consideration of the media, and then it takes hold of everything that passes through the process. So simply because with measurement, especially for petroleum products, there are challenges with flow measurement. of course, and because we need accurate and reliable measurement, and then we have a lot of regulations as well. So that has to be complied with. And then because the cost of energy is very high, especially in recent times, it's nearing $100 per barrel. It's very important that the flow configuration is the right one. And then because the business, of course, has to be responsible, and then for sustainability as well. So I have just put up here just a diagrammatic, graphical view of a LACT unit. So I will just walk us through. Basically, the LACT unit is composed of some components, and then with all these systems put together, it becomes a system that helps in having a very good and reliable measurement. So this system just shows one stream, but this can be 1, 2, 3, 4, 5 streams, depending on the number or the volume you are measuring. So we have just one stream here. Majorly on the LACT unit, you have the flow meter. I'm pointing it here with my mouse, and then you have the transmitters here, both for your pressure and your temperature. And then you have the prover here. And then you have all the data that you are measuring, both your flow and your temperature and pressure, of course, are sent to the flow computer. Now, the flow computer has the software, and which is an algorithm that does your temperature correction to base conditions, and then you can store your results on the computer or print them as you may wish. Around this side, we have the auto sampler, which has been, which is being talked about a lot, and this helps in checking the quality of whatever whatever you are flowing through your meter. So the auto sampler takes you a representative sample just for you to analyze to know whether the volume you have, your meter has recorded, whether what percentage of it is water or is sediment. So next slide. So essentially what the LACT unit does is that it measures the net volume of and the quality of liquid hydrocarbons, just like I've mentioned. So usually a LACT unit is basically designed based on the process media. You have the flow rate, the viscosity, the temperature, the pressure, and also ambient conditions. So on the, I have mentioned, you have the meters, the auto sampler, the instrument transmitters, the flow computer, and of course the prover. Now, looking at considering hydrocarbon loss reduction, I have talked about the LACT unit, but one other part of it is that for us to reduce loss in the upstream sector, one of the things we need to do is to make sure we monitor our pipelines. Because now the pipelines, as they are in Nigeria, there is little or no automation around the pipeline. So it's very difficult to know on time that there is an issue in the pipeline. So one of the things I have suggested here on this technology overview is that apart from the usual measurements that we don't do with the LACT unit, there is need for us to have pipeline monitoring. And I've suggested here that we have clamp-on ultrasonics. And then for whatever you are measuring in your LACT unit and whatever is going on in your pipeline, then you connect this to a gateway. And then because most of the lines runs through areas where we don't usually have a communication network. So you send it to a satellite modem, and then you can have the data in a cloud storage, and then it can be accessed through a SCADA user interface somewhere, maybe in your office or in a data center. All these can be powered using very low energy providing equipment such as solar panels and also very small wind turbine. So with this setup, it gives room for anyone or for any operator or for the regulator, as the case may be, to be able to see what is going on from any measurement system, the LACT unit off or on the pipelines. The next slide will show us a little bit more. So for pipeline monitoring, generally pipeline systems, just by way of mentioning, are susceptible to a variety of integrity challenges due to theft, excavation activity, geohazards, and then the internal corrosion as well. Then the loss of hydrocarbons, especially in Nigeria, is mainly due to third-party interferences on the pipelines, and also sometimes failure of the pipelines due to integrity issues. So pipeline leak detection systems are engineering systems used to detect leaks of different material from the pipeline and to alert the operator to leak incident. So we can actually monitor a pipeline using fiber optics. We can also use vibroacoustics and also the clamp-on ultrasonic that I showed in the previous slide. Okay, so I had earlier on shown the hardware side of it. So on the software side of it, we can have the device agents on IoT. On IoT, we can have graphical user interface to display what is going on. So an operator can have visuals, and then we can set custom alarms so that, for example, if we're expecting a flow rate to be maybe 10 meters per second, and this has reduced to maybe 7 or 6 or so meters per second, you have an alarm to show you on the dashboard that, hey, something is happening at X location, because you have, for example, clamps on all along the way. So you can number them one by one, and then you have them in your software where you can identify where an activity is going on. So with this, you can have all the data at every time aggregated. You can have your flow calculations going on and all that. So one of the things that is very, very important in the industry is metering calibrations. This, since we are talking about loss reduction and then reduction in the light of the value of the crude we are sending into the pipeline. For us to have some sense of having to know exactly what is passing through the meter, the meters need to be calibrated every time, and then we need to have a factor to correct what is passing through the meter. If not, we cannot attest to the integrity of the meter. So as required by regulations, metering calibrations are very, very important. So another thing that I've mentioned before on the LACT configuration is the auto sampler. So what this does is that it takes a representative sample that passes through the meter. So if you can imagine a scenario that you want to buy some volume, and then let's say we're using a bucket, and then you just fetch in the bucket. So you fetch in the bucket, you don't know how much is the valuable crude inside, because of course, water is free, but then you need to pay for the oil. And then if you just fetch in a bucket, you don't know how much is the water and how much is the oil. And if you end up paying for it, you'll just be paying blindly. So in order to ensure that you're having value for your money, you need to have a sample of what is there in the bucket, and then you analyze it to know that this is sediment, this is water, and then this is the crude that you need to pay for. Okay, so still on BS&W, the sampling and BS&W analysis. So the main purpose of sampling, just like I mentioned, is to get a representative sample. Okay, so so you get just a small volume, depending on the volume you have passed through. Let's say, for example, if you send in 10,000 barrels, you may be required to have 2, 3, or 4 liters. And then for someone who sends 100,000 barrels, obviously we expect, based on the regulation and the rules, if you send 10,000 barrels and you have 4 liters, if you send 100,000 barrels, you should be able to have 40 liters. It should be a representative sample, and then it should be your auto sampler should be flow dependent. And then this sample needs to be properly mixed and then extracted for analysis. So here I have put up here the standards used for sampling, very popular standards. The API chapter 8.2, and also the ISO 3171, and then the IPS 6.2. And then for you to analyze your BS&W to acceptable standard, then you need to follow either API 10.4 or the ASTM 4006, which is most preferred because this is the distillation, this analysis by distillation, and so that tells you more of the components. But if you need a spot check, you can use the D4007, which is using the centrifuge. So we've been talking about the role of technology. So let's talk about the role of people, because obviously this technology will have to be manned by someone, even though we've been thinking about automation. Automation cannot take place, obviously, without people. So the personnel handling metering system should be well trained. This is very important because if you have someone who is not well trained, he may not know the difference between a 0.1 and then the 0.11, because the difference of 0.01 in 1 million barrels is huge. Okay, so the person should have a good grasp of the algorithm used in metering system calculations, have good understanding of the system, and keep good records, because it's very important that the metering system, as a rule of thumb, the data should, for every meter proving, should be kept, for every meter maintenance should be kept. Each meter is supposed to have its own data. So this data should be stored in a retrieval system that can be referred to at any time. You can pick up and know and say, oh, this is when last we proved this meter, this was the beta factor, this was when last we carried out maintenance. For example, for a PD meter, you can say these were the clearances that were there. And so you'll be able to refer to it to know whether your meter is doing well or is not doing well. So the people should ensure that all metering systems have current certificates or certification, and this must meet the minimum regulatory requirements or exceed it, and then have a good understanding of the business implications of measurement, just like I've mentioned before. Okay, so here I have just put in a graph here just to tell us that, for example, if you send a batch of 500,000 barrels, and if crude is worth about 100 USD per barrel, this tells you the kind of, this chart tells you that your level of measurement uncertainty increases with the kind of measurement that you have made. So once, if the measurement uncertainty increases, this also increases the cost as well. So for example, the example I've shown before, if say you have 0.5% measurement uncertainty in the 500,000 barrels, this could easily be translated to $250,000. This could be plus or minus, depending on whether you're looking at the uncertainty in the positive side or in the negative side. So the implication of loss reduction via proper metering, accounting, and people's skills cannot be overemphasized at this stage. So in conclusion, your measurement system, your measurement system is only accurate when you consider all the factors that can affect it. Your instruments must be with current calibration, and you should know that calibration is key, because as simple as if you have a temperature transmitter that reads wrongly, maybe 3 or 4 degrees difference, that can be huge when the volume is large. Because if you are considering maybe a cargo, let's say 1 million barrels or 950, as the case may be, and then you have your transmitter having a 5 degrees difference to the true value, that can mean a lot of money. And also, secondly, your BS&W measurement is very important. The test method you use too is very important. Calibration of provers and meters are also very important, because that gives you the points at which you can correct your volume. Product monitoring in pipeline is important to reduce loss due to third-party interference and integrity issue. So finally, I would just like to say loss prevention is important, as inaccurate measurement can have serious damaging consequences and can be the difference between a company making a profit or a loss. Thank you. That's the end of my presentation.
Thank you so very much, Engineer Harry Dangyang. Please can you put a hand together for him? There's a huge difference between 0.01 and 0.11. And that will decide whether the business still stays afloat. Without further ado, I'll quickly go into the next panel session, where I'm still asking Mr. Engineer Henry to please stay online, because I think you're going to join virtually this session. And it's a great honor that the chairman is going to be moderating this panel session. So please, can we put our hands together for Mr. Olorushola as he comes up and takes his seat in the middle. He's going to be moderating this section on the topical issue, effective hydrocarbon management and loss reduction in upstream sector. And to join him on the to join him on the, please put your hands together for the chairman as he comes up. The staircase is just there, so you climb up, or you, okay, if the chairman has laid this protocol, it means the staircase has been suspended. So wherever it is convenient for you, sir. All right, this panel session is just going to be for 30 minutes before we go for lunch. And I'm very sure my team we ensure that lunch is ready so that we can come back for the 2 final sessions. And so, Mr. Chairman, I'd like to invite certainly the representative of the Chief Executive Officer of NUMPR to please come up. NUPRC, pardon me, please come up. I'm not too sure. My glasses needs to be changed. Engineer Abel, as you come up to, well, Chairman has given the protocol. If you choose that one, it's still your choice. So whatever is convenient for you. And then certainly Dr. Musa, Dr. Akin Musa, please come up to join them as well. Please put your hands together for him. From the NUPRC as well. I'd like to also from Trexim, Jude Mbaibu, I'd love to show your salutation, whether engineer, doctor, as the case might be. Is Jude here? Is Jude here for Trexim? Is he here? Okay, perhaps he's going to join us virtually. And I would like to also invite up to join them Engineer Patrick Akor. Engineer Patrick Akor. Please, can you put your hands together for Engineer Patrick Akor? He was the one who was in charge yesterday. It's good to see you, sir. And of course, Henry, you are joining them virtually. The chairman is going to ask the necessary question. And Ola Fatona to please come up and join them as well. Ola, excuse me. Ola, please, can you come up and join them as well? All right, that is Zip Automation. I guess that is it. I'm sure I have my number correct. Dr. Kim is there. Engineer Patrick is there. It's just Jude. That, okay, it's great. So you are the one that almost confused me whether there was a metering error, you know, but you have now balanced and closed the loop. So, Mr. Chairman, for the next 30 minutes, sir, the topical issue on effective hydrocarbon management and loss reduction in upstream sector, sir. Over to you, sir.
Just wondering how to divide 30 minutes by how many people here? All
Hello.
right. Okay. Thank you very much. So it's going to be a very, very quick one. And we've heard quite a lot from various speakers already this morning. So we'll be talking around, at least brainstorming around the topic of effective hydrocarbon management and loss reduction. But just very quickly, I know pretty well that the span of hydrocarbon management is pretty wide. Okay, so it includes things like looking at your governance and the institutions, looking at how do you manage your acreages. It includes things like technical as well as operations, which is the main things we're actually discussing today, with emphasis on metering and measurement. It even includes things around fiscal systems that you actually put in place. It includes things around how do you manage your stakeholders, especially the host communities, for example. So the gamut is pretty wide. And even recently, some jurisdictions have actually even included things like revenue management. How do you really manage the revenues that actually come from the hydrocarbons at the end of the day? To have, if you like, a very smooth ecosystem of hydrocarbon management. What I will do, gentlemen, if you don't mind, is just I won't do a cool thing like Pato noise. No cool things here at all. I'm going to do really hot stuff. But I'm going to just give you guys, let's say, because I want this audience to actually interrogate you very well. So I'm going to give the audience at least 6 minutes from the 30 minutes. Therefore, you can only do like 3 minutes each. Just depose anything that's in your mind around this particular topic. How do you think we can improve the effectiveness of hydrocarbon management? and reduce losses. And then after that, I could then ask 1 or 2 questions, but like I said, I really want the audience to actually do the probing. Okay? All right, so maybe I'll just take it from you, Abel. Yes, the regulator, exactly, regulators well, please.
Very much, sir. And I'm also very comfortable sitting with my boss. Just like he said, we'd like to go through hydrocarbon management. We'll have to go through the whole value chain from, during the speech I made, I talked about imaging deeper horizons and so on. So those are all still parts of hydrocarbon management. We're also looking at a scenario where for field development plans to, sorry, I'll be hinging on what the regulator is doing vis-a-vis the PIA. Remember, the NUPRC is a child of the PIA, just as the chief executive keeps reiterating at various fora. So it's a child of the PIA. So what are we doing? Everything we're carrying on is with respect to the PIA. And so let's start from looking at Africa as a whole. There's also a map you like to show, sir, whenever we sit like this. What Africa was in the 60s, in the 70s. I wonder whether you have that map. It would be nice to show it today. And so we put ourselves in a position where there is competition today. It's unlike in the 70s and so where you could call Nigeria really sitting comfortably. Right now, Southwest Africa, Southeast Africa, Mozambique, and the rest of them, from the Pemba region, you're seeing competition coming in from tremendous amount of gas. Namibia, 20 years ago, everybody talked about Kudu gas, supplying gas to South Africa. Today is different. Large number of rigs are going into Namibia. So whatever we have on a global scale, the advocacy for climate change and so on and energy transition is getting louder, so we can run away from that fact. Therefore, we have to produce responsibly. The key word there is responsibly. Energy transition, we took out close to 2 decades bringing out the PIA. And as the PIA comes out with all the lofty, beautiful things in the PIA, the whole world tells you that we want to move away from fossil fuels. However, you have to look at the fact that Africa is not really the main pollutant. So therefore, the key phrase or issue there is Nigeria, energy transition, energy security is also one of the major things we have to sit on. Therefore, we have to utilize what we've got and use it properly. Section 1A of the PIA talks about lots about the gas management. If you recall what the Petroleum Act used to say with respect, I think that was section 35B1, which had to do with flare. That's what we moved all the way to what the PIA is doing. So if you look at the gas master plan started 2007, yes, therefore. So which took everything with respect to infrastructure blueprints to move things like gas, for instance. I think this meeting is predominantly about gas and so on. Where we are, and I remember you are the director of petroleum resources pushing for the gas network code. How do you move gas in an open access scenario? So that has gone, is commissioned, the NMDPRA is managing that. And there's this handshake between the NUPRC and NMDPRA where they come up with what's the gas requirement for Nigeria. And so we have to run an algorithm and manage that from, because remember, it's coming from the upstream side of things, and it's going to run through where the midstream manages all that. So the upstream will put that in place and issues out a domestic supply obligation. How is that domestic supply obligation moving? There are challenges of infrastructure going around the country. Therefore, on a short-term basis, we have to come together and say, this quick short-term base will do with virtual pipeline movement, where infrastructure is not there. Major backbones like OB3 not being fully completed, the AKK, which provides those hubs to provide for CNG loads and mini LNGs and the rest of them for the country. So yes, from a PIA perspective, from hydrocarbon management, we've put in things all across the whole value chain for the upstream sector. Remember, DPR was part of what is today NMDPRA as well as NUPRC. So that, and come up with the robust fiscal provisions in the PIA. There's provision for management, proper utilization, production, and monetization of gas, if you want to look at it the gas way. So lots of things are in place. Let me yield back a little bit. But you see things like harmonious relationship with the environment. The last speaker never spoke about that, but so that protection of that asset that goes through that region. So we're taking into consideration post-community related issues. So management not just moves on the technical side of things, but also on the human and other necessary aspect to push that much forward. So I look forward to when we ask questions, we can talk about all that generally. Thank you.
Thank you very much, Abel. So pretty straightforward. Nigeria is basically focused on energy security at this point in time, but to responsibly accelerate value capture of all our hydrocarbon resources, whether oil or gas. You also talked about the fact that we need to get better at managing natural gas development, especially with all the instruments we put in place in terms of metering, network codes, infrastructure networks, and all that. And lastly, he also talks about the need for robustness in all our fiscal systems for investment attraction, as well as making sure that the host communities are happy. How you keep them happy, I don't know, but they just have to be happy in terms of fair sharing and general relationships. Okay, so let me then move on to Dr. Musa.
Yeah, thank you for inviting me to attend this very, very important conference. I want to thank the chairman for inviting me and the coordinator. This is an area where I consider it very, very relevant because revenues that's accruing to companies, to stakeholders, and Nigeria can be monitored, can be controlled. So your comment on the loss prevention and management of the metering system, I want to start by saying that we should look at energy, the energy sector, what drives the economy worldwide. Energy crisis can lead to war, it can lead to government change, can lead to poverty and the rest of it. So in terms of Nigeria, our revenue is mostly from crude oil and gas. So let's ask ourselves a question. Where were we? Where we are now? And where are we going? That's the... Of course, we do know that we have been operating in the analog model, and people have to constantly go to the field, physically carry out some operations, and then to even determine the volume, the accuracy of the meters. But recently, of course, where we are is that there's some places where we have remote monitoring through RTU or SCADA systems of some very important facilities that handle petroleum. And you can use transmitters from the source of that crude oil to a remote control room, kind of, so that you can see what is happening. And of course, the NUPRC, as at when I left, by the way, I'm retired, but I'm not tired. So when I left, we have the National Production Monitoring System, which are digital platform configured and tie into all the terminals, the purpose of which is to ascertain through real-time monitoring the daily production as it comes into the various tanks in the terminal. And the terminals are located either offshore, land, or swamp. And these equipments are digitally monitored, and we have the system right there in our Lagos office that senses the production. I think we've even gone far to even assess, put some systems such that from the well where the crude oil is initially coming out from is monitored, though the composition of that crude oil or gas coming out from the well is mixed with water, gas, and wax, sometimes sand, which needs to be processed. And we try to monitor that too. And then the terminal, which is where the actual export takes place. We have a metering system that handles the export measurement. And that is one of the best, hierarchy number one. We call it hierarchy number one because it has to be properly designed. So yeah, so to summarize what I'm trying to say now is that where are we going? We have to, number one, automation. Because we're in the digital age, we have to automate from the wellhead to the pipeline. We can have sensors on the pipeline, and then of course in the terminal. And that applies both to crude oil and gas. Proper design and calibration. I want to talk a little bit on this proper design. When
maybe,
okay, I've shifted the.
Maybe you can do that during the rounds of questions.
Okay. So let me just round up with
yes,
proper design and then revision of the laws, existing laws, and the guidelines, so as to capture recent trends and equipment that will help us get proper measurements, and then of course host community. All the design, the operation should be in line with environmentally friendly
acceptable
system. So the host community will also benefit. Thank you very much. And thank you for the patience.
Thank you. Thank you, Dr. Musa. It's always a problem when you give the professor something, the microphone. The next thing now, you will give us homework. But I think he hit the nail on the head. He was actually focusing more on the equipment, the fact that since energy is of great importance to national development, especially our country, Nigeria, the robustness of metering or measurement equipment has to really be top-notch, not just because of accuracy, but also the repeatability of it, actually. So it's quite important. And this morning, we talked about the fact that gas measurement or metering is much more sophisticated than oil. And he actually also touched a bit more also on that. Let me yield to another professor, Patrick. Oh yeah, but no homework, please.
Hello. Yeah. Yes. We are all here talking about how to maximize our measurements. How do we achieve that? Yesterday, we tried to go through appraisal on measurement. Today, all I have is to now look at the accuracy we're all looking at. when we talk about accurate measurements, what is involved? To start with, we as the operators, service providers, stakeholders are involved. Even my big people here, NUPRC, NMDPRA, are involved. In short, they have to champion on how to achieve this. I'm glad that in the recent procedure guide, a lot of things were mentioned on how the procedures were laid out on how measurements should be carried out. In this forum, Dr. Musa mentioned about equipment. The equipment we use in measurements of our fluid in the field. Also, the equipment we use in calibrating or validating those in the field. Most especially, that we use to validate the ones in the field. How accurate are they? They have to have traceability. And having traceability for those providing the services, from my experience, run into losses as a result of carrying or sending even a hard communicator or frequency generator across for validation services. Also, even NUPRC or MDPRA in their guide says some of the things we are sending out, they want to monitor overseas. That too, for me, there is great money loss on some of either the service provider, even the NUPRC. What stops us from having some of the laboratories in the country? Can't we partner with other national or international body over there? When you look at the national, unquote, Nigeria is a nation. Can't we have a standard laboratory of reference to some of our devices? When you look at the presentation from Engineer Henry, he summed it up on accurate measurements. Now, if I'm to carry out an accurate measurement, I must have to bring in an accurate device, a precision device. For me, I would like to recommend that as we get into maximizing metering exercise or measurements, the relevant bodies should endeavor to look into providing good laboratory. Like in my presentation yesterday, when I was with Kent German global company, we were able to bring in a test bench on gas metering. As in Port Harcourt at the moment, many people don't know of it. So we use gas and air as a medium in validating turbine meters, rotary meters, and diaphragm, and so on and so forth.
We have 30 seconds left.
So, yeah, in summation, we need, for accurate measurements, we need to have traceable equipment. And for us to get that done, we need to lessen the burden on the side of service provider. Thank you.
Thank you again, Patrick. We'll make your metering manifesto available for everybody. He gave us a very lengthy one yesterday. But indeed, he has also emphasized on accuracy of measurement as a way of reducing or minimizing uncertainties. Talks about validation, traceability, transmission of data, and all that stuff. But your recommendation for a national lab of as a reference for metering systems, I think is pretty apt, and thank God the regulator is with me here. Thank you very much. Let's move on to Mr. Fatono. Nothing cool, man.
Yeah. So, well, my senior colleagues have already said a lot. What I would just say is I'm a big believer in technology. A lot of us know what happened over the weekend with football, where Liverpool was denied a goal and they released the audio just to rectify things. So I believe that technology leads to transparency. If you have your data coming from the site and it's being sent to multiple offices, like the head office, the regional office, and everybody has copies of the data, there's a very little chance that data would be manipulated, because if it is manipulated at one end, it would not match up with what is at the other end. So I believe in everything I've said, talking about traceability, accurate monitoring. I also believe in real-time transmission and multiple copies of the same data that is coming from site. So if I know that the flow in Lagos, Abuja, and Port Harcourt have to match, then I'll be disincentivized from trying to manipulate anything, because it's going to be obvious to everybody, right? So that's, I believe that is a very, very key factor in preventing losses and encouraging accountability in the oil and gas sector. So.
Thank you. Short and simple. Technology is the solution. Thank you very much. Please pass the mic to, please go ahead. Thank you.
Good afternoon, everyone. My name is Engineer Jude Mbiebu from Trexim. I would focus more on selection of the right technology for metering. So we've seen certain cases as a service provider where end users actually use wrong meters for the right application. As a service provider, we are really being challenged with different things when we visit this customer. Starting from maybe metering engineer on site that feels like he knows everything, where you see cases where the regulators codes or their standards are not even followed during the metering. So in such cases, you're bound to have losses. You would see situations where companies use sort of like a flow meter that you know is actually good for oil metering, them using it for gas metering, and then that's ask questions. Why solar meter for this application? Take for instance, you have the case of flare metering. Is also at this point in Nigeria, sort of like physical metering. We've been challenged with convincing customers to actually use the right technologies, considering that the flare application is a very unique application, which is takes care of like waste gas, overpressure from the facilities. I mean, generally, most people use ultrasonic technologies, but you would also see cases where people would want to use like a differential pressure kind of flow meter for flare metering. We've tried it out a couple of places. The end users have tried it out, and in most cases, such technology fails. So we would always advise our customers to deploy the right metering solution for the right application. Then when you also talk about loss prevention in the facility, it also covers the protection of the facility. So I would always advise as a customer, if you're setting up maybe old or new facilities, you should look out for ways that you can prevent losses, which also includes facility loss. You need to make sure that there is a fire protection system available in your facility at every point in time. Then always carry out routine risk assessments within your facility. People operating facilities, they feel like it's something that is a routine thing for me, so I don't always have to review my procedures. We would also look at, I don't know if our regulators can also enforce something like that. Maybe annually or biannually, procedures should be reviewed. It must be reviewed because all of these all the losses that comes is as a result of minor occurrences. When you put these minor occurrences together, they cause a lot of issues. So thank you very much. And like my colleague here mentioned, deployment of the right technology to monitor such cases is very important. Luckily enough, we have OEMs that are residents in Nigeria that are always available to support both the service providers and the operators. So we would always ask that such companies should, even if you can't do it in-house, you can also consult and get it done. Thank you.
Okay, thank you, Jude from Trexim. We'll buy your tools. You can be sure of that. But really, it talked about the appropriateness of the kind of tools you actually really use for your metering of measurement, and then how to actually then protect them. And that then leads me to my question for actually all of you, really, because when we had the lead speaker from the online speaker, Henry from Belemau, he actually talked about all sorts of gadgets you can put, all the devices you can put along pipelines and all that to monitor anything that is happening. There was a time also we even tried to use drones, and all that, and it worked for a while. But after a point in time, the guys started plucking the drones, first of all, and as soon as they harvest the drone, then we are blank. The whole screen just goes blank completely. How do you guys think? And I hear people like Fatono talking about automation. How do we just make sure that we put enough wrap around some of these facilities, knowing where we are? I mean, this is the situation we find ourselves in our own. In some other places, maybe we don't even need all those things. But knowing where we are, how do we make sure that we actually improve the robustness of all this protection along all these facilities, both pipelines and all that? I know anybody who wants to shoot can shoot. Henry's still on the line too. Yes. Okay. This question too is for him.
So I would like to break the ice. Please, go ahead. Okay. Yeah. I have two solutions to it. Number one is security. Security of the pipeline. Because without security, whether you put in any equipment, any sensor, it will still be harvested and you are blanked off. Number two, my solution is we have sensors at every booster pumps, because these long pipelines have booster pumps along the line. So we have sensors that will give us the differential pressures, and we have sensors that will transmit such DP to the flow station, where if we sense immediately that there's a pressure loss due to theft, sabotage, or natural rupture due to corrosion of the pipeline, the production can be either diverted to a dedicated tank that would be able to accommodate, say, 2 weeks or up to 1 month. Yeah, it's like a backup, such that backup will give us a window during which the company will mobilize for fixing of the pipeline, and thereby reducing losses. and of course, revenue. Thank you.
Thank you very much. Any other support? So ultimately, would you still have to put human beings or some form of security? Okay, all right. Including gadgets. Okay, all right. So it's both real human beings and virtual human beings. All right, that's fine. Well, any questions from the floor then, before we begin to wrap up? So I have, okay, Henry wants to say something. Henry, go ahead.
Hello, can you hear me?
Yes, please, go ahead. Thank you.
Okay, so Dr. Aken Musa has mentioned security. I think security is key to infrastructure monitoring. Around the world, we've had friends in several other countries of the world. And it seems crude theft or product theft on pipelines seems to be highest in Nigeria. I have a friend in one of the eastern Russian countries, and he said they have over 1,000 kilometers of pipeline, and their reconciliation factor is usually 0.99. So, and the difference they have, it may be due to maybe the timing in taking the measurements, and it's not actually theft. So part of what operators can do, apart from the usual government security forces, is to ensure that communities are carried along and there's a model we use in my company, and I'm not selling my company here, but it tries to help to carry the community along so that they will be the protection for the pipelines and for the infrastructure, such that when you have a deployment of technology, the pieces of equipment and instruments will not be harvested within a short time. And I think we really need to look at poverty and then the job creation along the corridors where we produce crude oil and gas. And I think the PIA has helped a lot in putting up a framework for carrying the community along. The enforcement is what regulators need to really
Thank you.
Thank you.
Thank you, Henry. I have also visited, I don't want to mention the name of the country. I've visited one or two countries when I was in government myself. And all they did was electrification. So the major pipelines are heavily electrified. If you move 10 meters close to it, you are gone. You are frozen. Yeah. But I'm not too sure how how we want to do that. But indeed, and as at that time, this was like 12 years ago. As at that time, the level of losses, you're even talking of about 15-20%, not the kind of astronomical level we're even seeing here. I'm sure if they see things like we see here, probably the electrification will even be almost from a kilometer, but it worked for them anyway. So we just have to think of what really works for us. I see two questions here. One, okay, two, okay, 3, 4, 5. So we have 5 so that I don't want to take you away from your lunch. Okay. All right, so let's start from there. Please make it sharp question, not a whole page. Yeah, so that we can take it very quick.
Good afternoon, sir, and everyone in this conference. Ifeanyi Chukwu Samuel Ede. I'm always concerned about our fixation on Niger Delta. We have several basins. I'm a geologist. So sorry, that bias will always show up. We have other basins that have gas. Nambra Basin, Benue Trough, and all that. I'm always concerned with the current issue of pipeline issues we are having. And we know 80% is human-driven. It's human-driven. Let's be sincere. Why should we always want to take, we're looking for gas, and we have gas in all these basins. Why should we want to take a long-distance pipeline that we pass through remote locations prone to several vandal issues? Is it not better we segment, we look at the basins, look at the things we want, gas to power? Is it that the basins doesn't have enough gas? But I don't think it's so. So my question is, like I heard the regulator mention the issue of virtual pipeline. Can we try to look at the costs as against taking it from the basins that are closer? If we take it from the basins, will it not be better for us than to go this way of doing long pipeline and trying to secure them? Thank you.
All right, we have taken note of that. Please just take note and we'll answer them together. Thank
Chairman,
you.
is the minister's rep raised his hand?
No.
Okay.
Did he? That has to be priority now. You can't come all the way from Abuja and you can't ask your questions. Please go ahead.
Good afternoon,
Honorable Minister Representative.
Good afternoon, the presenter and the team of panelists. Some things struck my mind when the last presenter started his presentation, because we from Trade Ministry, whenever they talked about trade facilitation and fiscal measures that has to do with revenue for the companies and at the same time for the government, we always come in. And in his presentation, he talked about importance of meter configuration. Among those points he's listed, he talked about the challenges with flow measurement. One of the things there again is regulatory compliance. And the last thing I captured was also increasing cost, driving the need for improved fiscal metering to ensure value for product. That is equity. There must be fairness, equity in the transaction between the producer of goods and services. And as the discussion goes on, among the panelists there, I think Dr. Musa and the next prof to him, he talked about where we want to be, where are we coming from? If we want to be somewhere, it has to be in line with international best practices. Prof raised issue of traceability. The issue of traceability has been well captured by UNIDO and European Union under Quality Infrastructure Project for Nigeria. And the headquarters is cited in Enugu. And the work is ongoing by the previous administration, and effort is still ongoing to address the gaps. Now, he also talked about failure of integrity issues. The question that struck my mind, how do we address this integrity issue associated with meter configuration? It is at the finger of our tips. The only thing we don't value in-country contribution. We prefer unimported this. The issue of, what do they call it, traceability has been addressed by BIPM and the International Organization for Legal Metrology. The BIPM handle the traceability of our measurements from here down to Paris. Then where regulations are deficient, OIML, International Organization for Legal Metrology, addresses it. Now, thank God for PIA. PIA has made a robust contribution in addressing Nigeria, in addressing hydrocarbon measurement. But I want to implore the key regulators, that is the NUPRC and NMDPRA, to extend collaborative programs to our department so that we can address some of these predicaments in this country. And that is the way forward all over the world. I am a member of National Conference of Weights and Measures of United States of America. I have been participating in their conferences for almost about 6 editions now. And the way forward is United States, they have NIST, National Institute of Technology, that has the Apex traceability standard, but they collaborate with API and the NIST collaborate with National Conference of Weights and Measures in solving problems that has to do with transparency, accountability. That is the way forward. Thank you, Mr. Chairman.
Thank you very, very much for that. And I think we're happy. This is your first time in yes. Yes.
Not on behalf of
okay.
Minister of Trade and Investment, because
we will
ideas are also welcome from the practitioner, and that is why we are all gathered here.
Thank you. Thank you very much for that. All right, the next one.
Good morning, everybody. My name is Olamide Banjo. I work for a subsidiary of Midwestern. We are into crude transportation, Umugini Pipeline Limited. One of the things my first question goes directly to the NUPRC. Most of the time, if you go to the NUPRC portal, you don't have clear-cut regulations when you compare it to what you have with API standard. This is Nigeria. We have API standard regulations. We need to also look at areas where we can adopt some of these regulations to suit Nigeria. If we have to take the API, we have to quote it. We don't mind. You can quote it verbatim for verbatim. Most times, what you see is on the portal, you have to add call regulators to API standard, which is generally known. So we might need to look into that, number one. Then two, the last speaker, Jude, he actually mentioned something. We don't have standard when it comes to measurements for hydrocarbon. We need to have specific. Yeah. It needs to be clear-cut specific. When it comes to if you have to use a meter, going forward, we need to look at the next 5 years. Yes, where are we today? Where would we be in the next 5, 10 years? What do we do in the next 5, 10 years? My facility, we use a Coriolis meter now, which is well known for good measurements. In the past, it used to be sonic meters, PD meters. Now, going forward, would there be a regulation that will say, okay, for clear-cut hydrocarbon measurements and for precision in your hydrocarbon measurements, because you have errors on your PD meters, you have errors also associated to your sonic and the rest. But if you have, also these are things that we need to start looking at. Where are we today? Where do we want most of our facilities in Nigeria?
I think
I still have one more question, sir.
Oh my God.
The question is, as regards to
if
theft.
it's a short one.
It's a short one. Okay. As regards to theft, how do we manage theft? I can use this on the TFP line. It's been very funny for the past years. Yeah. But recently, our reconciliation, our CF factor, recovery factor is better.
It's a lot better. Yeah.
A lot better on that line. Yeah. Now, how do we, when vandals are arrested, what is government going to do? Do we have something that we need to have clear penalties for vandal and their cartels? Thank you.
Thank you.
All right,
Thank
Chairman,
you. Thank you
the
very
third
much.
or fourth question. Who raised their hands up here? Did you? Are you sure? Okay. Don't get me in trouble with Chairman.
Good afternoon, everyone. My name is Suleiman Osman from First Year MP. Mine is kind of a comment, and in addition to what Mr. Henry Hamza said, the role of people in metering. The people that must operate the metering has to be in the right state of mind. A meter can be 100% accurate, but what if you have the wrong person there? What happens? Thank you.
What do you mean by the right? If the person is hungry.
Right state of mind. Yeah, if he's hungry, then something can be wrong. He can impute wrong data, and if you have wrong data right from the source, we're all in trouble.
I get the message.
All right, the next question, I think we have the last one after this.
Yeah. Good afternoon, gentlemen and ladies. My name is Stephen Owoltem. We've talked about the effective hydrocarbon measurement and loss reduction in upstream sector.
Yeah.
But I feel that the regulators has not done enough to actually address some of the issues that the operators are going through.
Yeah.
And there are situations where representatives of the regulator wouldn't even accept to go to some remote locations to witness recertification, to witness meter proving as required by the provisions of the law. Sir, I would want the regulator present, to speak to that. And I also want to quickly add that we are talking about losses. It appears to me that the fundamental things are actually not being addressed, because I tell you, there are quite a lot of operators that are bleeding as we speak.
Sure.
And the fact is that the incidences of vandalism, sabotage, flow line, and all that, they are not being reported as they ought to be reported, to draw the awareness of those that are supposed to address them. And lastly, I also want to say that vandals that are caught should also be made to face certain punishment,
okay,
to also discourage others.
Which is in line with
the mindset.
All right.
All right.
Maybe death penalty or something.
Okay, good afternoon, everyone. My name is Tebet Mwadike from...
Oh, Stephen. Yes.
Okay, my name is Tebet Mwadike from Walter Smith.
Yes.
Yes, my question somehow goes to the regulators. Yes, we are talking about accuracy of carbon accounting. But you see people that are not trained, people that don't even know about hydrocarbon accounting. In hydrocarbon accounting, that is one, it's a major source of error. Then secondly, in metering, you see people that don't even know about metering, doing metering. Just as he said, service providers that don't even have good knowledge, good background knowledge about metering, doing metering jobs. That is a major source of error that you may not even be able to eliminate. We also see among ourselves, operators, see somebody that has an instrument background, he claims to know metering. It's a major source of error. Because your background is instrumentation, you cannot do metering if you're not properly trained. So I want the regulators, both of them, to say something about it. Thank you.
All right, Mr. Chairman, the last question, I guess that's the final one then.
I was worried because
yes,
he was almost going to say you are a chemical engineer and you are the MC of this event, but that's okay.
Thank you, Mr. Chairman, and good afternoon, everybody. My name is Engineer Uche Obala from Accela Limited. By the way, we are into natural gas and energy. We are in oil and, energy, gas and energy sector. So my question is around unaccounted for gas. in line with what we've been discussing concerning hydrocarbon measurement, accounting, and loss prevention or control. So it's a contentious issue in the industry because there's no way you can run a facility without having losses. Majorly for the gas business, we do experience some fugitive losses. We do experience some third-party damages and all sorts of losses here and there. And over the period, we found out it's been an issue between the supplier and the off-taker when it's time for reconciliation. So the issue now is, do we have any benchmark internally or regionally as per what that figure will be? It could be a range, it could be a reference benchmark, but today there's always this struggle between the supplier and the off-taker as per what will be the benchmark for the UFG. So the percentage is always contentious. So we need to find out from the regulator, do we have or do we plan to implement that? Thank you very much.
Thank you. And that also has even a link with the climate-related emissions and all that. We do now. Okay. All right. So thank you very much. We'll just give you sharp responses. It won't be as long as the questions, but it will hit the points very well. I think you just shoot at once, isn't it?
Thank you, sir. Thank you. These questions are quite they are profound. With respect to unaccounted for, I can start from the back. Okay. With respect for unaccounted for gas, we do have a regulation, and there are plenty regulators within this environment. If I'm not answering well, I'll get Janice within the audience to answer. Yes, we do have regulations. Remember, the previous regulations was for flare. We do now have a regulation which takes care of fugitive emissions. Is that correct? Yes, we do have that. I also mentioned to you a few other regulations are coming, but remember, it's got to go through the processes through Federal Ministry of Justice to align that and get us to roll that out. The answer is yes with respect to that. The other one is manpower development with respect to those who go for measurements. Part of the issues, key focus areas from the PIA as it relates to management of hydrocarbon resources includes facility engineering initiatives. And we do have proof of concept. The major technologies you bring in, just as somebody was speaking about good oil field practices elsewhere, we get your technology to go through a proof of concept procedure before we roll it out. You can remember at a certain time, it was a major challenge to bring in ultrasonics with respect to gas measurement, AGA chapter 3 and so on and so forth. We needed to see that that was acceptable and it was tested within a period, and we got Shell to put 1 or 2 sites as pilots for this. So it goes through a rigorous procedure. And someone spoke about why must we concentrate on the Niger Delta? No, we do. Part of what we're to do based on the PIA mandate is the de-risking of frontier basins. It's in the PIA. That's ongoing. And we do also have generated regulations with respect to this. So when you say, so for that, that's in place for proper management of resources that are outside of the Niger Delta. It goes through the necessary provisions by law for what we're doing. Then somebody spoke about traceability, NIST and so on. If you come to put we go through that engineering with you, the whole concept, front-end engineering, detailed engineering, the procurement part of it, and where the whole points are for testing those procedures with you. The answer is yes, we do go through all that. And In there, some of you have read the procedure guides. For that acceptability is with traceability to NIS, the National Institute of Standards and Testing. Yes, we do that. I'm sure I've covered significance and take some.
Yes, I would like to leverage on what he has just said now. The first, I missed your name. No. Ifeanyi, he talked about why we should have virtual pipelines and long pipelines. So the virtual pipelines, they are necessary when we have unavailability of the trunk lines that take the crude oil to the terminal. So rather than shortening the well, losing production for both crude oil and gas, so the virtual pipeline will help take the crude oil to the nearest terminal, thereby keeping the company busy. So the cost of virtual pipeline is quite expensive. Cheapest means of transportation of crude oil the world now is pipeline. So virtual pipeline is a mitigating kind of action. Yeah, so that's what I will say on that. I think he has talked about the other one. So the second person from trade and investment talked about traceability. My colleague here has already spoken on that, so I will skip that one. Olamide from Upstream, he said there's no clear-cut regulation API to suit our Nigerian environment. No specific standards. Company use Coriolis meter, and yes, we do have standards. We have regulations. We have even guidelines that goes further to explain the step-by-step procedure. Yeah, so we have it, and I want to quickly say that technology seems to be ahead of laws, regulations, and guidelines. So they come in first. We now look at the cost-benefit analysis of those new equipment. We subject them to proof of concept and see how they are going to be applicable to our own environment, especially to our own type of crude oil. And when it's a process. And then when the reports come, we analyze it and it's fit. Of course, we adopt it and put it in our guidelines. I remember I chairman the revision of the guideline that introduced Coriolis meter into the industry. Then Usman from First EMP said, wrong person at the metering system. So I would say it's like putting square peg in a round hole. Definitely for such skilled labor or work, you require the right person with the right training, with the right discipline to be there. I can't imagine myself as a doctor of chemical engineering, and because I bear the name doctor, they take me to the surgeon in the hospital that should operate somebody because I simply bear the name doctor. I will allow you to imagine what will happen. So, Mr. Stephen, say witnessing of lacked system at remote location, incidences of vandals, loss of report, consequence of management. Okay, the witnessing of lack at remote locations. Obviously, I want to say from my own experience, some of these locations are so remote. They are, and that is why, if you remember when I said about automation, we can introduce automation. And I want to also advise that if you see that kind of incidents, for now, since we are still doing physical calibrations and meter proving, please, you'll find a way to meet the necessary people who handle it. So, Nwadike from Watersmith said no training for hydrocarbon accounting, wrongful placement, and I think it's similar to
the same question.
Yes, the same question. So you don't put a round hole.
Thank you, Dr. Akin.
The last one, Uche Opara, she talks about fugitive losses, wrong accounting for gas. So
that was already
said he has already answered, so I'll skip it too.
Thank you very much.
All right.
Any other?
Yeah.
One more.
Yeah, my contribution here is to thank the minister's
Comments.
comments. I'm happy to hear from you on weight and measure, calling for collaboration with NPRC and NMDPRA. It's a good call as far as I'm concerned, because it's going to help us in the measurement exercise. Why? Because definitely you'll come up with something substantial in terms of equipment, a laboratory that could be referenced to. Thank you.
All right, thank you very much.
Yeah, quickly.
Good. Last one.
Quickly, this is even part of the collaboration we're doing now today.
Yeah, absolutely. Jude.
Okay,
Any other one?
I'll just help any PRC with the question that Mr. Wadike asked.
Okay.
In terms of having the right company,
Sure.
carry out the
Go
right
ahead, go
metering
ahead.
job. So any PRC, they have some limitations. Certain companies just come up from nowhere and claim that they're a metering company. They apply for any PRC permit, the permit is being given to them. But I would also like to state that during your evaluation process, when you're trying to qualify your vendors, always try to cite evidence of jobs done in the past with references. If a certain service provider comes to you and says to you, I can carry out this metering job for you,
Sure.
it's your responsibility as the operator to qualify that vendor properly. We've also seen cases where company A knows how to do the job, but is more expensive. Company B is cheaper or more affordable and cannot deliver the job. The operators most times would rather go for the affordable companies, and it causes a lot of problems because at the end of the day, when the job is not being done properly,
Sure.
you spend money twice. You still come back to
do it
the right
again.
person that gave you the right offer technically and commercially.
Thank you. Thank you.
Sorry.
Dimeji.
Yeah, I feel I want to slightly disagree with you.
With automation.
No. So in the sense that I understand the point of trying to get the jobs done, right?
Sure.
But what happens to a newly formed company with duly trained personnel who don't have proof of jobs done? That means you are effectively squashing the small guys and saying only the big guys with big projects can get jobs. So fundamentally, I respectfully disagree with that.
All right, that's okay.
Yeah, so what I would say is that there should be a standard framework. So anybody that passes that framework, in my industry, we have something called TUV. You are TUV certified, you are TUV certified. Because TUV is respected, and for you to have gone through the system, they know that you are worth your salt. So we should have something like that. If you scale through that, and everybody knows that there's a standard reference, then you should be qualified to get the job.
Thank you.
Yeah,
Patrick, one comment from
yes,
you.
Another comment on this issue. I want to use myself to illustrate their comments. As we sit here, I'm being called to provide documents in the past 3 years for particular services.
Okay.
Under my company's name, Railwood Nigeria Limited. Meanwhile, I've not been given such job, but I have a qualified experience all over. What do you think I should do? If I tell them I don't have, I can't show any evidence of previous 3 years. Meanwhile, I've done this job over 10, 15 years, even in that present company. But they are requesting for 3 years. What happens?
I mean, I know it's such a dilemma, but I don't want this to continue because the food is getting very cold, and I don't want to put the wrong people on the right equipment. Just to also add to, I think Ifeanyi, you're the one who said we should move away from the Delta now. And move to other business where there's plenty of gas. You only be there for 2 weeks. Those people will meet you there. So let's stay and solve the problem where we are first, and then we can then move to all the other places and exploit fully. On that note, please join me to thank all these guys on the panel, as well as Henry, who joined us online.